Hello everyone. Am I audible? Am I audible to everyone? Yes. Okay, so everyone, please congratulate Nayan Kumar. Nayan is the winner of yesterday's contest. Okay, we will crown Nayan this time. Okay, so guys, Nayan solved all the problems of the previous assignment in the least amount of time. Again, today also we are going to have assignment based on what we are going to study today, and the person who is going to solve it in the least amount of time is going to get a t-shirt. Okay. Okay, so should we begin the class? Great. So guys, today we are going to see a set of problems, a set of patterns of problems which can be solved using a specific technique called two pointers. Okay. Now, this technique is not restricted to only two pointers. You can have two pointers, you can have three pointers, you can have maybe k pointers, you can also have one pointer, just right. So all these types of techniques fall under this umbrella term, which is called two pointers. Okay, and there are multiple problems. This is one of the favorite topic of the interviewers. Amazon, Flipkart, Microsoft, all of them ask many problems based on this topic. Okay, so whenever you are solving a problem which is based on two pointers, or whenever you are studying this topic and then you are practicing the problems, you always have to be very mindful about 4 points. What are the 4 points? The 4 points that you have to be very mindful about are, if you are selecting a pointer, what is the physical significance of the pointers? Okay, and when I'm saying pointers, I'm not talking about the C pointer, I'm not talking about the star, I'm talking about an index. Okay, by pointer we mean I and J. Okay, the index are the pointers in this case. Okay, so you have to be very mindful, very conscious about 4 things. One of them is, what is the physical significance of your pointers? What do we mean by the physical significance? Physical significance means, what does the pointers represent? Because pointers might represent a range, right? A range from I to J, or they might also represent a pair I comma J, or they might represent some other thing, right? But you have to be very conscious about what the pointers are actually representing. Okay. The second thing that you have to always keep into focus is how to initialize the pointers. Now, this thing will change from problem to problem. Okay. So whenever you are using this approach, you will start the pointers from some point. So what should be the starting point of each pointer? In some cases, you would want to keep one pointer at the start of the array, the other at the end of the array. In some other cases, maybe you would want to keep a pointer at the start and the other pointer in the first element, or the just next element after the first of the array. In some other cases, you might want to start with keeping both the pointers in the same element, right? So what is the initialization process of the pointers, from where to start? That is something which is very important in all the problems. Okay. The third thing, which is very obvious thing, is how to change the pointers. Okay. By changing the pointer, we mean how to move the pointers. Okay. So, do you want to move the pointer forward? Do you want to increment the value of the index? Do you want to decrement the value of the index? All these things come under this point. Okay. And the last but not the least is when to stop. Okay. These are the 4 things which you should always focus on whenever you are practicing any problem on 2 pointers. Okay. Should we see the first problem? Okay, so the first problem is a very commonly asked interview problem. This is one of the most frequently asked interview problem. Okay, the problem says, and this is most frequent in companies like Amazon, Flipkart, Microsoft, Snapdeal. Okay, the problem says that you are given a sorted array. Okay, you have to find the number of pairs which have a sum equal to k. So you are given a sorted array, and then you are given a number k. You have to find the number of pairs from that array such that their sum is equal to the given number k. For example, let us say that the array that you have is 1, 4, 4, 5, 5, 5, 6, 6, and 11. Okay. Now, if the value of k, let's say, is 10, or let's say is 11. If the value of k is 11, what should be the answer? How many pairs are there which are giving us a sum equal to 11? We are not supposed to count single elements. We are supposed to count pairs. Okay. The complete pair should give us a sum equals to the given value k. Okay. So here in this case, we can see that if you just if we just index these elements, okay. So in this case, I'm getting 11 from 5 and 6, where 5 is present at index 3, 6 is present at index 6. Then I'm again getting 11 from 5 and 6, where 5 is present at index 4, 6 is present at index 7. Then I'm again getting okay, let's keep it index 3 itself. So there are 2 pairs which are giving us 11, which are involving this 5 present at index 3, right? And then there are going to be 2 pairs which will give us 11, which are involving this 5, right? Again 5 and 6, and 5 and 6, which are taking the 5 present at index 4, okay, and then 6 present at 6 and 7. And then there are again 2 more pairs which are giving us 11, right, where the 5 is coming from index 5. So in total, how many pairs are there? There are 6 pairs which are giving us 11. How to solve this problem? SK equation, that is in the right direction. Now, many of you are saying that you can use a hash map, right? If you use a hash map, that is definitely going to be a correct approach that will give you answer in order and time complexity, right? But what is going to be the space complexity if you are using a hash map? Space complexity is also going to be order n. Now, in this problem, you have to solve it without using this extra space. You have to solve this problem using a constant amount of space. Amit Kumar, that might not work because you just have to find two pairs. You have to find the pairs. Now, one element of the pair can be present here. The other element can be present here. So sliding window is not going to work. Definitely, sliding window will work if you are dealing with sub arrays where you have to find some of continuous elements, right? Okay, let's make some observations. Okay, let us make some observation. Let us say that if this is my array, okay, and this is a number x and this is a number y, okay, what would be the brute force approach if I'm giving the array in sorted order and if I have to find the pairs which are giving the sum equals to the given number k? What would be the brute force approach? Let us start with brute force and then we'll try to optimize that. Okay, the brute force is that you fix one element, right? You fix a pointer in one element, iterate over the remaining array and see whether you are getting a pair which is given a sum equals to the given number k. Then you change the first element and then again you iterate over the remaining array and then again you find the pair. So you will be trying to find the pair for each and every element one by one, right? So the brute force approach, which will have two nested loop, is going to cost you order n square. Okay. Now, what is the brute force approach doing? The brute force approach, if you have x and y as two elements in this array, for x you are iterating over this complete array, right? You are checking each and every value and you are trying to find out whether you are getting a sum equals to k or not. My point is that if there is another number y in the array, a random number at any random position, right? And if I say that x plus y is greater than k, can I make any decision here? If x plus y is greater than k, can I say that x plus all these numbers will also be greater than k? Or can I also say that if x plus y is greater than k, then all these numbers plus y will also be greater than k? If this is the case, then x dash plus y will also be greater than k, where x dash is any number which is present on the right side of x. For all x dash which are on right of x. So for all these numbers which I have encircled by the red color, for all of them, if I take their sum with this element y, I will definitely get a number which is greater than k. Why? Because if a smaller number, this array is sorted, right? Do not forget this. The array is sorted. So if a smaller number is giving a sum which is greater than k, then all the numbers which are larger than this number will definitely give a sum which is greater than k. Similarly, if x plus y is less than k, if x plus y is less than k, in this case, what can we say? If this is less than k, can we again make another decision? Right? So based on the sum, since the array is sorted, based on the sum of any two numbers in this array, I am able to discard some portion of the array, right? So I don't need to do this brute force search. The search that we are doing for each and every element, that can be optimized because the array is sorted and we can discard some part of the array, right? Okay, so if x plus y is greater than k, then definitely if I try to increment y, that is of no use, or if I try to increment x, that is of no use. So what should be the decision that we can take in this case? If x plus y is greater than k, then we can try for a smaller value of y, right? If x plus y is greater than k, then we have to reduce this sum. Incrementing this pointer will increase the sum, right? So let us try to decrement this pointer. Similarly, if x plus y is less than k, then you can try to increase this pointer, right? Now you can quickly find out that if you start a pointer from the start of the array and you start another pointer from the end of the array, right? You can just initialize a pointer start, which will start from 0, and another pointer will be end, which will be started from the last index of the array, right? And now we can say that if a of start plus a of end, if these two are forming a sum which is greater than k, what do? We can shift this pointer towards this side, because if you shift this pointer, that will further increase the sum, right? So we can do and minus minus, okay? Else, if a of start plus a of end is less than k, what can we do? If these two numbers are forming a sum which is less than k, we can try to increase the value. Now we can only increase the value if we are incrementing the start pointer, right? So we can do start plus plus, okay? Else, if a of start plus what is the last case which is remaining? The only case that remains is, I don't need to write this whole thing. The only case that remains is what if the sum is equal to k? In that case, what can we do? If the sum is equal to k, so we have seen that if this sum of these two is greater than k, you decrement this pointer. If the sum is less than k, you increment this pointer. What if sum is equal to k? Can you just return the answer? No, right? The question says, what does the question say? The question says that you have to return the number of pairs. You don't have to return true or false. This is not a binary question, right? You have to return the total number of pairs. In this case, we had to return 6. 6 was the answer in this case. How do you return 6 if you are just returning true? Okay, so some of you are saying increment count. Okay, let us increment count. But what do you do with the pointers? Do you increment the start pointer or do you decrement the end pointer? What do you do? Okay, now some of you are saying that you can do any of that, right? Okay. Let us copy this example and let us try to analyze various cases which are being proposed. So this is the example that we had, okay, and the sum that we have to form is equal to 11, and we are starting the pointer, the start pointer from here, the end pointer from here. Sum is greater than 11, so we increment we decrement the end pointer, right? And then we find out that sum is less than 11, so we increment start pointer. Again the sum is less than, we again increment the start pointer. Again sum is less than 11, so again we increment the start pointer. Now when the start pointer points to 5 and the end pointer is pointing to 6, sum is equal to 11. What should be done in this case? Count plus plus, that is okay. We increment count by 1 and now we have one element. Some of you are saying increment the start pointer or decrement the end pointer, that is same. Okay, let us try to do that. If I increment the start pointer, okay, have I missed anything? Now again I'm getting a pair. So count is increased to 2. Then I can again increment the start pointer. Again I'm getting a pair. Count is increased to 3. Again I increment the start pointer. I'm not getting sum equals to 11. The answer that I'm getting is equal to 3. But answer should have been 6. This is wrong. Why is it wrong? Because when you increment the start pointer in the first place, when start is here, end is here, you have incremented the count by 1. When you are incrementing the count, start pointer to here, you are missing out on this pair. This pair has not been counted, right? Or maybe you have actually counted this pair, but this pair is not being counted, right? So you have missed out this one pair. If you decrement the end pointer, then again you will be missing out on one of the pairs. If you increment and decrement both of them, then you will be missing out on many such pairs. So what should be done? So if such a case arises, in that case, we'll have to be a little logical. Okay, we will have to come out of the pointer thing, and you will have to think in terms of maths. Okay, if you see that 5 and 6 are valid pairs, they are forming a valid pair, right? Now there can be multiple copies of 5, there can be multiple copies of 6 as well. And each and every 5 is going to form a pair with each and every 6. If there are 3 5s and there are 2 6, each 5 forms pair with each and every 6. That is why we have got 6 pairs, right? So a simple thing that can be done in this case is you just count the number of 5s, count the number of 6. You cannot directly add to the final answer. You will be counting the number of first element, you will be counting the number of second element, and then what is going to be added in the answer? Your answer is going to be answer plus count 1 into count 2. Number of 5s multiplied by number of 6. Does this make sense to everyone? So in this case, you can say that count A of start. Okay, count the frequency of A of start. Let us call it C1. Then you count the frequency of A of end. Let us call it C2. And then you can do answer plus equals to C1 into C2. Okay. Now you will have to implement a while loop to do this, because you will be also incrementing the pointer. You will have to have another while loop here. So this is going to be something like while A of I is, maybe you can have a value temp where you can store A of I, and then you can just say while A of I plus 1 is not equal to temp, right? And then you increment the or A of start, and then you keep incrementing the start, okay, till that value is there. So for all the 5s, you will iterate over this section, and then you will count this. For all the 6, you will iterate over this section, you will count, and then you will add the product of the counts in the answer. Does this make sense to everyone? What happens to the pointers now? Pointers are incremented, right? When I'm saying that you count the number of this element, let us see what happens to the pointers. So initially, start is fixed here, end is fixed here. When you are counting, you are simultaneously increasing the pointers as well. You are simultaneously moving the pointers as well. So when you are counting the occurrence of 5, you will move start pointer here, then you will move start pointer here, and then your start pointer comes here. So you have counted that there are 3 5s, okay, before jumping to 6. Similarly, you will also be counting this thing, the occurrences of 6. So you will jump your end pointer here and then end pointer here. So before reaching to a number which is not equal to A of end, you will also decrement the value of the end pointer, okay, and then you reach a situation where your end has surpassed the start point, right? End has become less than start pointer. What is this condition? Srinivas, your the array that you have given is not sorted, you have to be very, very careful while listening to the question. Okay, don't, if you are attending the class, please don't attend it half-heartedly. Pay total attention. Okay, you are given a sorted array. Do you mean what is a? Do you know what is a sorted array? All the numbers have to be in increasing or decreasing order, right? So in this array, you are given an array which is sorted in ascending order. Now check your input. Is that sorted in ascending order? Okay. So this is just a simple while loop. This is just a simple while loop, and then you count these numbers, you multiply them. Okay, now Tejasvi has a very interesting question. She is saying, what happens if sum is equal to 10? Let us try to analyze this. Okay, that is a very, very interesting point that has been raised by Tejasvi. What happens if value of k is not 11, value of k is 10? Okay, so we will be counting all the pairs from here and here for between 4 and 6. When my pointer, start pointer reaches 5 and end pointer also reaches 5, okay, is the same approach going to work in this case? Is the same approach going to work if the value at a of I is equal to value of a of n? If these two are equal, can I say that multiplying the count will always give me the correct answer? No, right? This is not going to give me the correct answer. Why? Because when you are counting the occurrences of the first element, you are counting all these 3 5s. When you are counting the occurrences of the last element or the end element, again you are counting these 3 5s. So the total number of pairs that you are going to get is going to be 9, which is wrong. Why? Because you are counting this 5 with itself again. Okay. So how can we deal with this edge case? You will have to check, you will have to have an extra condition here. So now in if the sum is equal to k, you will have two conditions. One is that if a of start is not equal to a of n. If this is the case, if both the values are different, then you can simply count the occurrences and multiply them. But what if both the values are same? In that case, if you have, let's say, n values, choosing any two of them is going to give you the answer, right? So in that case, what should be the answer? So this whole you have to do only if a of start is not equal to a of n. If a of start is equal to a of n, in that case, you just count the values, count the number of occurrence of that number, and count C2. This is going to be the answer. Okay. So you will calculate count C2, because if you have 3 5s, right? If you have 3 5s, you have to count the number of ways in which you can choose 2 5s out of these three. Right? That is going to be the answer. Okay. Now the question is, how many times do we need to do all this thing? How many times do we need to do this whole thing? So first of all, let us go back to the points that we have written. Is everyone clear about what is the physical significance of the pointers? Physical significance of the pointers is that pointers are representing pairs. I is pointing to one element, J is pointing to one element, right? So pointers are representing a pair. How to initialize the pointers? We have initialized one pointer from the start, the other from the last. How to change the pointers, that we have seen. Okay, in based on the cases, we are either incrementing one pointer or we are decrementing the other pointer. Now the last condition is when to stop. When to stop? So we have already seen this thing, that we can stop if your start pointer becomes greater than the end pointer. Okay, so you can write the base case here, that you have to do all these things while your start pointer is less than the end pointer. Okay. Now let us try to calculate the time complexity. What will be the time complexity of this approach? What is the time complexity? How many times are we visiting each and every element? That is the question. Even though you are going to have a while loop here and a while loop here, what is the total number of times we are going to visit each and every element? Right? So every element will be visited exactly once by one of the pointers, right? So that is why the time complexity is going to be equal to order. So we have solved this problem with a time complexity of order n. And what is the space that we have used? We haven't used any extra space, right? So space complexity remains constant. Okay. Can you please explain for sum equals to 10? Okay. So I will quickly iterate over the last point which was raised by one of you, that what happens if ai or a of start and a of end takes the same value. Okay, so we have seen that, let's say if the sum that you have to find out is 10 and one of the pointer is pointing to 4, the other is pointing to 6. In this case, what is the total number of elements? What is the total number of pairs that we can have? This 4 will pair with both the 6. This 4 will also pair with both the 6. So count of 4 multiplied by count of 6. This is what we have concluded. Count of one number multiplied by the count of other number. This should be added to the answer. The question which was raised was that what happens if both the numbers are same? So if you are finding a sum equals to 10 and your start is at 5, end is at 5, you will be counting the occurrences of a of start, which is count of 5. You will be counting the occurrences of a of end, which is again a of 5. This is going to give you 9 because this occurs 3 times. This also occurs 3 times. This is wrong, right? Why is it wrong? Because you are considering pairs between all of these 3 5s. So you are also considering this pair which is occurring between the first 5 and the first 5, which is wrong, right? So in this case, what we can do is simply we can say that we have got 3 5s and choosing any two is going to give us the answer. So that is why we said that if a of start is equal to a of end, then you have to calculate the count of that number and you can do C1 count C2. Or if you just want to calculate the count, this is going to be nothing but end minus the position of end pointer minus start plus 1, right? If one of the pointer is here, the other pointer is here, you just have to count the number of occurrences of these elements. You know that no other element can come in between because the array is sorted. So to count this length, you can directly do e minus s plus 1. That will give you the count and you can just do e minus s plus 1 C2. This will give you the answer. Okay. Cool. Should we now see the next problem? Can we extend the logic to number of triplet? That is now up to you. You have to think there is going to be a problem based on the triplets in the assignment. Okay, try to see if you can extend the same logic. There is a very similar problem which is also another very frequently asked interview problem and had been multiple times been asked in Facebook. Okay, the problem is titled as diff k. You can just Google the problem, or this is also present in the assignment, where you have to find the number of pairs whose difference is equal to k. Right? Currently, we found the number of pairs whose sum was equal to k. Now you have to find the number of pairs whose difference is equal to k. So again, in this problem, you will have to check from where to start the pointers, how to move the pointers. Okay, that is going to be very critical in this pointer. So just think about this. This you can take in homework. Okay, this is also there in the assignment. Try to solve it yourself. We'll try to see another very interesting problem. Okay, this is also a problem which has been asked multiple times in the interviews. Okay, The problem says that you are given three sorted arrays. Now listen very carefully. Okay. The problem says that you are given three sorted arrays. Let me just take the example. Okay. You have to find what is the minimum value of minimize the absolute difference between the maximum of A, B, C and the minimum of A, B, C, where A is any element that belongs to array A, B is any element that belongs to array B, and C is any element that belongs to array C. So basically, you have to choose three elements from these three arrays in such a way that the absolute difference between the maximum of these three elements and the minimum of these three elements is minimum. Is the problem making sense? Choose A, B, C. You have to choose A, B, and C such that A belongs to array A, B belongs to array B, C belongs to array C. Okay, such that this equation has the minimum possible value. You have to minimize the value of this equation. Is the problem clear? Merge and find the adjacent minimum. Okay, if you are merging the arrays, then if you merge the arrays, you will not be able to follow this constraint. Okay, this is a very important constraint. You cannot just skip this thing. A has to belong to array A. You need one value from array A, one value from array B, the last value from array C. If you are merging the arrays, I don't know how you are going to differentiate between which array the element actually belongs to. Difference uh, minimum in comparison to other differences, right? There are multiple possibilities of selecting values of A, B, and C. Out of all those possibilities, you have to select the values such that this difference is minimum, right? For example, you can pick A equals to 1, B equals to 6, and let's say C equals to 2. In this case, what is the answer? The minimum of ABC is 1. The maximum of ABC is 6. So in this case, the answer is 5, right? Another choice would be that you take A equals to 5, B equals to 6, C also equals to 6. In this case, the minimum is 5, the maximum is 6. So the answer is 1. So this is lesser with respect to the other values, right? So this is going to be the answer. Yes, Vaishnav has a very good observation. He says A, B, and C has to be as near as possible. Absolutely correct. Okay, Karthik has the brute force solution. Try all possible combinations, right? That is correct. But what will be the time complexity, Karthik? Okay, is what will be the brute force solution? Find all minimum and maximum values from all arrays. How will that help Amrit? If you find all the minimum values and all the maximum values, let us say this array also had 100, this array had a 200, and this array had a 300. Okay, and then you find all the minimum values, which are 162, and you also find all the maximum values, which are 100, 200, and 300. Now what do you do with these values? Sort all the arrays. Shivanand, arrays are already sorted. I don't know why you guys are not paying attention to the problem. The arrays are already sorted. If you are doing the sorting again, that is not going to help you. Okay, Sai Kiran, that is in the right direction, but can you point out which pointer are you going to increment? Which is going to be that pointer? Okay, guys, what is going to be the brute force here? Let us start with the brute force and then we will see how to optimize that. What is a brute force solution? Brute force solution is going to be that you have these three arrays, right? You fix the first number, and then you fix this number, and then you iterate over all possible values here. Then you change this, again iterate over all possible values. So you are actually considering all possible triplets, right? Check for what is the time complexity of checking all possible triplets. This is going to be order n cube, right? Now, let us try to observe the brute force approach, how the brute force is going to work. Okay, let us copy this example and let us paste this. So, whenever we are solving a problem, we always have to check that if the brute force is not optimal, why is it so? What is the redundancies that we are doing, or what are the useless calculations that we are doing in the brute force approach? Okay, so if you are running three loops, right, so you will be starting a loop which will start from I equals to 0 to array 1 length, right, and inside this you will be checking another loop j equals to 0 to the second array's length, and then you will be having another array which will start from, let's say, k equals to 0 to c's length, right, and then you will be checking for what is the value of this equation for ai, bj, and ck, right? My question is that initially ai is this number, bj is this number, ck is this number, right? I is pointing here, j is pointing here, k is pointing here. Okay, now what we are doing is, in the brute force, first you check these triplets, then you increment k, right? Then you change k to this. Is it going to change the answer? So initially, when you have I, J, K, and let's say that this is the answer. Okay, so I was at 0, J was at 0, K was at 0. What was the answer? The answer was the maximum of 1 comma 6 comma 2 minus minimum of 1 comma 6 comma 2. Okay, and the absolute value of this thing. What is the answer? Maximum of 1 comma 2 comma 6 is 6. The minimum is 1. The answer becomes 5. If you change the last pointer, okay, if you do this thing, 0 0 1, now you are taking the maximum of 1 comma 6 comma 3 and then minimum of 1 comma 6 comma 3. Again the maximum is same, minimum is same, answer remains same. is it going to help us? Is the brute force going to help us? Is like all these computation, are they useful for us, or are they useless? Right? Similarly, if you increment this pointer further, if you increment, because in the brute force, the next pair that you are going to check is this one, right? Again, these two are fixed here, this is fixed here, right? Now you have the maximum of 1 comma 6 comma 6 and minus the minimum of 1 comma 6 comma 6, right? What is the answer? Answer is still the same. If let's say you are incrementing it further, if you increment this 6 and you reach till 300 in the last iteration of the last loop, now what will the answer improve? Will the answer improve now? Maximum of 1 comma 6 comma 300 minus minimum of 1 comma 6 comma 300. Now maximum becomes 300, minimum remains 1. The answer now becomes 299. Has the answer improved or it has become even worse? Answer has become even worse, right? Why is it happening in this way? This is happening in this way. We are not gaining anything from this iteration because 2 was not the minimum, 2 was neither the minimum nor the maximum, right? And since the array is sorted in increasing order, if you are incrementing this pointer, you will only be going to change the maximum. You can never change the minimum. Does this thing make sense to everyone? So in the equation, you have got two terms. One is the maximum, the other is the minimum, right? If you have to minimize this value, to minimize this, you have got two ways to minimize this, right? If you want to minimize the value of this equation, what are the two things that can be done? Either you reduce value of max, right? Either you can reduce the value of max, then this value will, the magnitude will be minimized, right? Or you increase the value of mean. These are the two ways using which you can minimize the value of any equation that has a subtraction in between, right? Can we ever reduce the value of max? Can we ever reduce the value of max? All the arrays are sorted in increasing order. We are already at the minimum of all the arrays. If you are incrementing the pointer, can the value of max be ever reduced? No. So this is not an option in this case. What is the only option that we have? The only option that we have is increase the value of minimum. Okay. How can you increase the value of minimum? Can you increase the value of minimum without changing the pointer pointing to the minimum element? No, right? Out of 1, 6 into 1 is the minimum. So if you have to reduce the value of this equation, you have to increment the value of this minimum element. Okay. So how can we now optimize this brute force approach? We will again be starting from the three starting elements, but now to increment the pointers, we will again go logically rather than going in a brute force way and checking each and every possibility. We will do this logically. We will apply some mind and we will say that the only possibility in which I can reduce the value of my equation is that when I am increasing the value of the minimum term, when I'm increasing the value of this term, this 6 can never be reduced because any number, if you go on the right side, is definitely going to be greater than this 6, right? So we'll have to increment this value. How to increment this value? Increment this pointer to 4. Okay, let us copy this and then try to understand this whole thing. Okay, so now what we are going to do is we are starting from these three elements. Okay, so our I, J, K and the answers are here. So all of them are pointing to the minimum possible elements of these arrays. Okay, what is the answer? The answer is maximum of 1 comma 6 comma 2 minus minimum of 1 comma 6 comma 2, which is nothing but 6 minus 1, which is 5. Okay, now incrementing the pointer of 6 will increase the value of max. Incrementing the pointer of 2 is not going to affect the equation currently, but eventually is again going to increase the max. In both the cases we are going to get a answer which is even higher value. So what we can do is we can increment the pointer of the lowest out of these three. So now we increment the pointer of the first element. Okay, what is the next value of I? Now I is incremented to 1, J and K remains same. Now the answer becomes max of 4, 6 and 2 minus minimum of 4, 6 and 2. What is the answer? The answer in this case is 6 minus 2, which is 4. So now you can see that we have improved the answer, right? We have been able to minimize the value. Okay, let us let us see what happens in the next step. In the next step, which out of these three is the minimum, having the minimum value? If I increment 4, that does not change the minimum. If I increment 6, that also does not change the minimum. That actually increments the maximum. So what is the only choice that we have? We will be incrementing the minimum out of all of them, which is 2 in this case, right? So now this is 1, this is at 0 again, and this becomes 1 as well. So now the answer becomes max of 4 comma 6 comma 3 minus minimum of 4 comma 6 comma 3, and now the answer becomes 3, right? So now you can see that the answer is reducing. Okay, are you able to get the approach now? Is everyone clear regarding this whole idea? What are we going to do in the next step? In the next step, we will again be incrementing the pointer of C because it was pointing to the minimum value. Now this becomes 0, 2, and what is the answer now? Maximum of 4 comma 6 comma 6 minus minimum of 4 comma 6 comma 6, which is 2. Answer is further improved, right? Now 4 is the maximum, so you can increment this pointer. This is now pointing to 5, and now we can say that this pointing to 2, 0, 2, and now you will be having max of 5 comma 6 comma 6 minus minimum of 5 comma 6 comma 6, which is nothing but 1, and this is going to be the answer in this case. Okay, is the problem clear to everyone? Now a question is, what if two values are pointing to the same minimum? That will happen in this case. So in the next step, we will be incrementing the value of this pointer to 8. In the further next step, we have two minimums. Both these pointers are pointing to the minimum element. If you increment any of them, you will get the same answer. Why? Because if let's say you increment this pointer, in the next step this will be incremented, so that will be counted. Or if you increment this pointer, and then in the next step again you increment this, then in the further next step this will be incremented, right? So all the possibilities will be explored, no matter whether you increment the first one or the second one. So if two pointers are pointing to the same value, if you increment any of them, that is fine. Okay. So what will be the time complexity of this approach? What is the time complexity? Can you please clarify why should we not decrease the max? Janvi, we should definitely decrease the max, but we cannot decrease the max. How can you decrease if you are already starting from the minimum values of all the arrays? If you are already at the minimum value, is there a chance, like you can just try any possible value that you can have? If you are already having the minimum value, how can you decrease the maximum, right? You have to select A from array A, you have to select B from array B, you have to select C from array C. You have selected the minimum of array A, minimum of array B, minimum of array C. There is no number possible which is less than 1 in array A, no number possible which is less than 6 in array B, no number possible which is less than 2 in array C. So there is no chance that you can minimize the maximum of these three. Whatever you are getting as the maximum is the minimum possible value of the maximum. Okay, just take some example, try it out yourself, and then you will understand. Okay, so what is going to be the time complexity? Time complexity is going to be the maximum of these arrays, or in the worst case, let us say that the sum of the length of all the arrays, which is going to be linear, so we can say it is an order n solution. Okay, is there any name? This is just a 2-pointer variation, you can call it a 3-pointer. Okay, this will not work for okay, escape creations, just try to find that out yourself, will it work or not? Okay, try to do some brain exercise and try to find that answer. What if all three values are same values? Psychiran, if all three values are same values, then guys, please always focus on what you have to find. Okay, don't get lost in the algorithm. Always focus on what is the final thing that you have to find out. The final thing is the minimum value of something which is placed inside absolute operator, which is placed inside mod. If all three values are pointing to the exact same number, what is the minimum? First of all, what is the minimum answer that you can have? The minimum answer that you can have is 0, right? You cannot have a number, an answer which is less than 0, because this is placed inside this absolute operator, right? So if all three numbers are pointing to the same value, do you need to further do anything after that? You get the answer 0, right? Then you don't need to do anything else. You don't need to increment or decrement any of the pointers, because 0, nothing less than 0 is possible. Okay. So there, if you get 0, you can directly break. Okay. Link of the question. This question is present in today's assignment. Okay. The link of assignment will be there in the description. Okay. So guys, time is up. We have one very interesting problem to be discussed. But maybe we can discuss that problem. Is two pointers used mostly in sorted array? No. Okay, so I will just give you a brief intro of the next problem, and maybe you can try to attempt this problem yourself. Okay. So the problem says that you are given an array uh, and this array represents the height of sticks or height of bars. Okay. So this array is unsorted array. Let us say that the array is something like this. Now this is again a very frequently asked interview question and also a very interesting problem. Okay, so all these numbers here are representing the length of bars. Okay, so the first bar has a length equal to 1, then you have length equal to 8, then you have 6 and 2 then 5, and then 4, 8 again, and then 3, and then 7. Okay, you have to find what is the maximum area between any two bars. What is the maximum area that can be formed? Rainwater, right? This problem is also called container with most water. So you have to create a container using these bars such that volume of the water. So volume is not 2D thing, but hypothetically, the volume of the water should be maximized. So in this case, if you select this bar and this bar, in that case you will be having this much of water inside them, right? So so this much of water will be inside them, which is how much is what is the amount of the water if all the bars are placed at a unit distance from each other. This is going to have a length of 7. Similarly, here also only 7 length will be counted, and then 7. So 7 into 7 is 49 is the answer in this case. Okay. Is the problem clear to everyone? You have to find what is the maximum area between any two bars. Is the problem clear? So again, what will be the brute force for this? Let us start with the brute force solution. What is the brute force? Just see that the bars are not sorted. So one of you asked that is two pointer applied only in a sorted array? No, not necessarily. You can apply two pointers anywhere if you are able to make a decision using which you can move the two pointers. Okay, that decision is very important. So in this case, what is going to be the brute force? The brute force is that you select each and every bar one by one and check what is the maximum area that this bar is going to give, that you can have with this much of height. So I will fix my height equal to that of bar 1, and then I will iterate over this whole array and we'll try to find out what is the maximum area that we can have with this height. Then we can select this bar, and then we'll again iterate over the remaining array and try to find out what is the maximum area that we can have with this bar, and so on. So this is going to give you how much? This will work in order n square time complexity because you are going to have two nested loops, right? Okay. Now my question is, can I say that if there exists a bar of height 8, right? You have a bar of height 8 here, you have a bar of height 8 here, okay? If you know that this bar is already present, is it useful to calculate the area of this bar with all these bars in between? Are these calculations that we did in the brute force approach even useful? You know that there is a bar of height 8 after a certain distance. So in between these two bars, all the bars are of smaller heights. Can I say that area of this bar between any of these bars is always and always going to be less than the area between these two bars? Yes? Right? So what do I have to find? For each and every height, I have to find the farthest height which is equal to or greater than this height. right? For any hi, instead of actually iterating over all the heights and calculating the area, if I can somehow find what is the farthest bar which has got a height at least equal to hi, right? So I want to find out a hj, right? So if I write this, I can write it that the maximum area for any height hi comes from or comes with the farthest, right? The farthest bar, farthest height hj, such that hj is greater than or equal to hi. Okay. If I am able to find a bar which is farthest from the current bar and has got a height of at least equal to this bar, then I can say that the maximum area of this bar is going to come from this hj. In between, I can have multiple bars. So for example, if I have one bar here and one bar which is longer than this bar, and in between I have multiple bars, right? They may be equal to or greater than this bar, but I want the farthest bar which has got a height less than or equal to this bar. This is going to be the maximum area with this height. Does this make sense to everyone? None other bar is going to give you this much of area. Why? Because the height is fixed at this point. This is the maximum height that you can have. The only thing that can vary is what is the width. To increase the width, you need the farthest bar, right? So this is the farthest bar which has a height greater than or equal to this fixed height, right? So for this bar, the answer is always going to come with this given bar, right? So if instead of doing a brute force like this, can I say that if I do a brute force in opposite order, for example, if I am fixing this bar of height 8 here, but to find the pair, I am going from the opposite direction. This is going to be more optimal because I will not, as soon as I find a bar that has got this much amount of height, I will stop because that is the bar which is going to give the maximum area with this bar. Does this thing make sense to everyone? I don't need to start from this direction. I can actually start from the opposite direction, and as soon as I get a bar which has got at least this much of height, I will stop, calculate the area, and change to the next bar, right? But in the worst case, this is also going to be order n square solution, right? Let us say we have got these bars. Okay, what I'm saying here is that if I'm trying to find the pair for this bar, instead of iterating on loop like this in this direction, start from the farthest bar. If you find that this bar has got a height at least equal to this bar, then we are very sure that this area is the maximum area that you can get for this bar, right? What if this bar is not having a height equal to this? Let us say that here we had a smaller bar. Okay, now do I need to run a loop in this direction? If the height of this bar is smaller than the selected bar, can I say that this is going to be the maximum area for this smaller bar, right? Why to fix this height? Whichever is smaller, the area is going to be maximum for that height, right? If I'm not getting a pair for this, If I'm not getting a pair for this, it doesn't, nothing to worry, because I am getting a pair for a smaller bar. Anyone out of these two which is smaller, I will be getting the pair for that bar, right? Does this make sense to everyone? So the initial observation that we did was that if we have to find the maximum area for this bar, we just need to find the farthest bar from this bar which has got a height at least equal to this much. Then we said that what if we are not getting a bar which has got this much of height? What if these bars are smaller on the other end? Do we need to run a loop and try to find a bar for this? No. If you are not getting a pair for this bar, you are getting a pair for this bar, right? Because this is going to be the maximum area that you can form for this much of height. So although you didn't get what is the maximum area for the first bar, but you got what is the maximum area for the last bar. So what can we do? We can decrement this pointer. Now we will be checking for this bar, right? Again, we see that this is the smaller bar. So what is the farthest bar having a height equal to or greater than this bar? So we have again got what is the maximum area for this bar, and then we again decrement this pointer. Now we have got a bar which has got a bigger height than this bar. So now we get the area, what is the maximum area for this much of height. So now we can increment this pointer, and then we find out what is the maximum area for this bar. So then again we increment the pointer, and so on. Does this make sense to everyone now? So what are we doing in this approach? We are fixing one pointer in the first bar, we are fixing another pointer on the last bar, and we calculate the area as whatever is the minimum between the start and the end, right? Because that is going to be the height, a of start and a of end. This is the height multiplied by the distance between these two, which is going to be end minus start, right? Or end minus start plus 1. And then whichever is minimum, you just move that pointer. So if this bar has got a smaller size, you increment this pointer. If this bar has got a smaller size, you increment this pointer. Okay, does this thing make sense to everyone? Right, so how will your code look like? You can directly say that you are fixing a start pointer at 0, you are fixing an end pointer at n minus 1, and if the a of start and if a of, so first of all you will calculate the area, right? You will say the area is equal to, let us also, area is equal to maximum of whatever is the current area into minimum of a of start comma a of end multiplied by the distance, which is n minus start, right? So once you calculate the area, you will just check if a of start is less than a of end, then you do start plus plus, else you do n minus minus. Okay, and how many times you have to do this? You will be keep doing this till you find the pairs for each and every bar, which is, what is the condition for that? Till start is less than end, because once start and end become equal, the distance is 0, so the area is going to be 0, right? So we will be doing this whole thing till start is equal to, and in the end, in this variable area, you will be having the answer. Okay. We need the farthest index. So Shivani has a question that we need the farthest index. Shivani, just tell me, if you are starting one pointer from here, you are starting the other pointer from the end, don't you think that this is the maximum distance that you can get? You cannot have a distance greater than this, right? This is the maximum distance between these two. Now, since you have got what is the maximum area for this height, that now this height becomes useless for you. You don't need to calculate this area again. So you can increment the pointer and check what is the next height. Even let's say, even if the next height is same as this. Now for this height, right? For this height, you have already calculated the area. So if even if this value is going to be less, you don't need to worry because you have already calculated the maximum area for this height, right? So now this height is totally useless. You can again increment the pointer. Or if let's say in the next iteration you have a bigger bar here, so now you calculate what is the maximum area for this height, right? Because this is the farthest bar from this bar which has a height greater than or equal to this one, right? So now you can again increment this because the area has been calculated. Okay. What will happen for 8, 8, 7? Komal, just try that out. Try to see what will happen. Okay. Do some exercise yourself and find that out. Is the logic clear to everyone? We started from the brute force. The brute force says that check all the pairs. Okay. Check all the pairs and then see whichever is the maximum. We said that we always need to find the farthest bar. So if you know that there is a bar of same height or greater height which is present at even larger distance, then that must be considered, right? So we said that let us start the loop from the other side. Let us start the second loop from this side. And then we came to know that we actually don't need this loop at all, because if you are not finding a pair for this bar, you are finding a pair for this bar. In every iteration, you are finding the pair for at least one of the bar, right? So you can do this thing in order and complexity. Okay. So guys, I hope this session was clear to you all. You learned something new or you solved some interesting problems. All the problems that we have solved are from the interviews of some of the top tech companies. Okay. And right from tomorrow, we are going to study searching. Okay. If you find this lecture interesting or if you want us to keep continuing the lectures, please do like, please write your comments, please give your feedback, please share the video, because if we see that there is no traffic coming here, then we might have to stop the classes, right? So if you want the classes to keep running, please do like the videos, do share the videos. Okay, I will end the broadcast now. Please solve the problems. The person who solved all the problems in the minimum amount of time is going to get a t-shirt. Okay, thank you all. Good night.